Let's take a second to interpret the relationship between velocity and acceleration. We know that if we have a position function, like s of t, then we can find velocity, v of t, by taking the first derivative of s. And then we can find acceleration, or a of t, by taking the second derivative of s. So let's start by calculating the velocity at t equals 1 and acceleration at t equals 1 for the position function t cubed minus 4t plus 2. So v would look like the first derivative, which is 3t squared minus 4, and then a would look like the second derivative, or the derivative of v, which would be 6t. And if we wanted to evaluate each one of these at 1, we can. So that would become 3 times 1 squared minus 4, which is negative 1. And then a at 1 would look like 6 times 1, which is 6. So we found v at 1. We found a at 1. Now we want to answer the question, is the particle moving from left to right or from right to left at t equals 1? So let's think about it. The velocity is negative 1, and typically t increases to the right. If our velocity is negative, then it would be going backwards. In other words, anytime v of t is less than 0, we know the particle should be moving from right to left instead of left to right. For part B, we want to know, is the particle speeding up or is the particle slowing down? Now we have acceleration calculated to be positive 6. Now we know that the object is actually moving backwards, but it's accelerating in a positive fashion. So because we have v of t less than 0 and a of t greater than 0, we know that they're working against each other. So think about if you're walking backwards and you have a certain velocity, like negative 1, you're walking backwards at a speed of 1, and then you start to increase your acceleration forwards. Well, that's working against you walking backwards. You're not walking backwards faster and faster. Instead, you're walking backwards slower and slower until eventually you would start walking forwards if you continue accelerating at a rate of 6. So the particle is actually slowing down because velocity and acceleration are working against each other in this scenario. Let's extend that idea to look at position and velocity. So again, we're given a position function, s of t. This tells us what position our object is at for any moment in time. Part A asks us to find v of t, so we will do that first by taking the derivative of s. And then part B asks us, what time, or multiple times, is the particle at rest? If the particle is at rest, then it must have 0 velocity. If the velocity is 0, then we can set our velocity function equal to 0 and solve for t. I notice that all 3 of these terms are a factor of 3, so let's factor that out and divide it off. Dividing both sides by 3, got rid of the 3. I still have 0 on the left side. Now I have a quadratic that I could try to factor. And if I use a negative 2 and a negative 4, I can factor that. then I can see that at time equals 2 seconds and at time equals 4 seconds, I will have a zero velocity. We can double check that by plugging 2 and 4 into our function. We will see that the particle is not moving. The velocity is 0. Part C says, what time intervals is the particle moving from left to right and from right to left? Now in the last example, we determined motion by looking at the sign of velocity. So let's draw a simple number line here for our t values. We know that at t equals 2, the velocity is 0, and at t equals 4, the velocity is 0. And so it's on either side of these t values that the velocity could be positive or negative. If we pick a number like 1, and we plug that into our velocity function, we can determine if the velocity is positive or negative for this entire interval. So if I plug 1 into any version of my velocity function, I could determine if I have a positive or negative velocity. I'm going to use the factored version of velocity. So 3 times t minus 2 times t minus 4. If I plug 1 in, I'll get 3 times 1 minus 2 is negative 1. 1 minus 4 is negative 3. Two negatives multiply to be a positive. So if I use 1 in my velocity, I get positive velocity, which means our motion would be moving to the right, from left to right. If I pick a test point between 2 and 4, like 3, I can plug that into my function. I would have 3 times 3 minus 2 is positive 1. 3 minus 4 is negative 1. I have one multiple of a negative, which would leave me with a negative velocity for this entire interval. From t equals 2 all the way up to t equals 4, I have a negative velocity, which means this particle is moving right to left over the seconds 2 to 4. And then after 4, I could pick something like 5. Plugging that in, I will find that I have another positive velocity interval. So the particle is moving again left to right. So if we wanted to answer part C using intervals, we could say from 0 to 2 and from 4 to forever. The particle is moving left to right. And then from 2 to 4, the particle is moving right to left. The last part of this example asks us to use the information to sketch the path of the particle along the coordinate axis. So if we'd like, we could draw our coordinate axis. Oops. Basically just a number line here. And we can use this to help figure out exactly where we are. So at t equals 0, if we plug 0 into our function, we would see that the function equals 4. So let's put some numbers on our number line. And I'm going to have these count up by 4, just so we don't have too large of a graph going on. So at t equals 0, our particle is at 4. It continues to move forward until we get to t equals 2. So from t equals 0, we move forward until t equals 2. And we move forward, landing at the spot where s of 2 equals. So we will plug in 2 to our function and we'll get out 24. So right here, we're at t equals 2. We moved forward until 2 seconds. At 2 seconds, our position was 24. And then after that, the clock continues, but we move backwards. So from t equals 2 to t equals 4, we're moving backwards. Plugging t equals 4 into our function, we find that we're at this point. We can kind of loop these together. After t equals 4, we start moving forward again. And we don't actually have a stopping point after we turn around. So we can continue forever. Time goes on forever, so this path of the object would go on forever. So again, t equals 0. We plug that into our function and we get s equals 4. And then we know that we're moving forward because we have a positive velocity until t equals 2, which at that point we turn around and we move backwards until t equals 4. Then we turn around again and continue on forwards.